And here we are at Pensacola Beach. This is the beach that I grew up in. And you can see that the day is about perfect. Crowds are starting to show up. This is still a locals beach, and you can see that there aren't big condos everywhere. There are a few. The iconic water tower is getting a little bit of a facelift. And the famous beach bar, The Dock, is where the old casino used to be before a hurricane and fire demolished it. And our island authority making sure everybody's being safe out here. When I grew up, this was where we started playing volleyball, and you can see there's still some old timers out here. And I figured, just like most teachers, you can't stop thinking about school, so what better place to do a quick lesson than with this scenery. So, let's talk a little chemistry. One of the things that we've talked about in the past has been the law of conservation of matter. And what this law means is that matter cannot be created or destroyed. Alright, now we've talked about this before, but this becomes really important when we start talking about chemical equations and how we want to try to make new molecules or chemicals. So as we start to make these things, what we start with has to be in our product somewhere. Alright, now before we start talking about that, we need to address one other topic. In nature, sometimes atoms exist as diatomic molecules, meaning they exist in pairs. Hydrogen, oxygen, and chlorine are examples. They exist in a molecule made up of two of those types of atoms. And they don't occur by themselves very often. Alright. Now, in light of us being by the ocean, a nice easy equation for us to start talking about is this one. Take the diatomic hydrogen, the diatomic oxygen, and I can create water. So one of the things to also think about is when we talk about an equation, we need to understand what the two sides mean. This side is a reactant side. This side is a product side. Alright, so our first step in balancing this equation is to draw these things called coefficient lines. And in math, we talked about coefficients being the number in front of a letter. This would actually mean there are 3 x's. But if I placed a 3 here, that would mean there are 3 H2O's. So the only way that I can get 3 oxygens, because this is a molecule, is to change my coefficient to 3, but it's also going to apply to my hydrogens. So I have a little catch there. Alright. The next step that we need to do is we need to count atoms on both sides. And before we do so, we want to verify that the law of conservation of matter is being violated. In this case, we have 2 hydrogens and 2 oxygens for 4 atoms. On this side, we have 2 hydrogens and 1 oxygen for 3 atoms. So since we don't have the same on each side, we know that we have to play with this equation so that it fits into the law of conservation of matter. Alright, our first step, or our next step, is to bring down these coefficients for hydrogen and total up how many hydrogens we have. Under this coefficient line, we're going to draw it and total out our oxygens. I always like to put an OXY so that I don't confuse this with a 0 for 20. On this side, in the same line as our hydrogens, this coefficient and our 2 hydrogens. And because this is a molecule, and whatever number goes here also applies to the oxygen, same coefficient line with 1 oxygen. Now, the law of conservation of matter says that these sides have to have the same numbers. So to do so, we're going to use a principle called the lowest common number. In math, if we had 2 numbers of 3 and 1, the lowest common number would be found by going like this: 3, 6, 9, 1, 2, 3, 4. And the 3's are the least common multiple, or number. So we're going to use the same concept to balance our equation. Alright, so typically we can start with the bottom atom first. And on this side we have 2, and on this side we have 1. So using our chart, we can determine that 2 is our least common number. On this side, since we have 2, we multiply it by 1 to get to 2. Carry our 1 up. On this side, we have 1 oxygen. We need to get to 2, so we have to multiply this with a coefficient of 2. And we're going to carry this up. So now our oxygen, we have 2 on each side. So now as we take a look at hydrogen, we have 4 total here. 2 times 2. And we have 2 on this side. So our least common number is going to be 4. We have 4 here. So this coefficient has to become a 2 so that we can get to 4. So we're going to carry it up. At this point, we have a number on every coefficient line. So we've balanced our equation. So the correct equation is this. Alright, well, there's a nice little short lesson, and since I am on vacation, I think I'm going to go and enjoy the fun in the sun.